So first of all, a very warm welcome to our talk. We have a relatively small crowd, but that makes us even more happy to give this presentation. Yeah, it's a long title. Rust meets the grid, building Openleadr-rs for real-world demand response. That demands some explanation. We're still some people coming in.
Let's wait a minute.
And we were asked to start really in time, but not sure. Okay, so to clarify right away a little bit, Openleadr is an LF Energy project that currently has 2 implementations that are part of it, of the OpenADR protocol. And OpenADR is for Open Automated Demand Response. The project that we will be talking about today is Openleadr-rs, and it's written in Rust, hence the name Openleadr-rs. In the next 30 minutes or so, we're going to first look at the problem we're actually trying to solve. We're going to, of course, dive into the project a bit more and also look at current adoption, which is going pretty well, and also future plans. Okay, but first let's introduce ourselves in a minute. And then the clicker doesn't work, of course.
Of course.
Now it does.
Yes, there we go. Thank you, Hugo. Good morning, everybody. Let's do a quick round of introduction. It's good to be here. My name is Smets. I work for ElaadNL at the moment. My background is in embedded software engineering. Not a lot of embedded going on the last few years, but at ElaadNL I've mostly been focused on protocol standardization. And I do that currently on different levels of the energy grid. So that's in-home EMS to device communication. But in the case of Openleadr, it's more between a DSO and a CPO party, for example. So it's a bit more high level. Yeah, then it's up to you.
Yeah, my name is Hugo. Nice to meet you all. I'm currently one of the owners and directors of a Dutch company called Tweede Golf. It has nothing to do with playing golf. And I'm also the secretary of actually a non-profit foundation called Trifecta Tech Foundation. What these organizations have in common is that they are both involved with doing software development in Rust. And Trifecta Tech is then mainly aimed at building open source projects written in Rust. And we've been involved with Openleadr since last year, actually. Okay, but let's get started and let's check out the problem that we're actually trying to solve here.
Yes, thank you. All right, I don't think it's any surprise what I'm going to tell for most people today here, but it's good to do a recap of why we started with OpenADR in the first place and why there was a need to build open source software in the form of Openleadr. As most of you know, at least, well, in the Netherlands, we have quite the issue with the electrical grid. Since we started electrifying our devices, our vehicles, we see a lot of stress on the electrical grid. I think most of you know, if we invest in the grid, these are investments done for the next 20 to 30 years. So once we have something put in the ground or above us, it will stay there. So with the current speed of electrification, we see that the grid is severely lagging in capacity. It's very much behind. And we don't have the capacity to actually replace every cable in the ground within the required time. So we are now looking for ways, while in parallel upgrading the electricity grid, to make smart use of the capacity that is there at the moment. And well, what we see mostly is that we now face very high peak demands while also leaving some space on the grid in between them. These peak demands are a very big issue at the moment for years already, and the issue is only growing bigger and bigger over time. Yeah, thank you. So if we look at the map of the Netherlands right now, this is, well, I don't see any green color. Green means good and red means bad. So it's mostly bad what's going on there. If you want to get a new grid connection, so this map refers to a 3-phase ADM connection, then you're simply not going to get it anytime soon, at least in most of the country at the moment. So you see that there is a shortage basically everywhere, with some limited capacity regions where you do make a chance of getting a grid connection within a fair amount of time. So this is really bad, and now we're looking for smart ways to actually use the limited bit of capacity that we have left while upgrading the grid.
I see this slide is a little bit off. Let me correct that. All right. So yeah, one of those smart ways is actually called demand response. Who knows all about it already? Maybe some hands? Okay. Okay, then let's still do a quick recap. So demand response is actually a fairly simple concept. It just means that the demand or consumption of electricity is going to respond to the actual availability of electricity or grid capacity. While historically this has been the other way around, right? If we needed more electricity, we would just ramp up production and the grid would balance out again. So we want that demand actually follows supply now, and we can do it by rolling out so-called demand response programs. And from the perspective of a network operator, say a DSO in the Netherlands, it means sending out price signals or temporary usage limits, all to influence consumption behavior and to help stabilize the grid. And terms that you often hear in this context are peak shaving and load shedding. It's very much related. Peak shaving is mostly to when you talk about reducing the morning and evening peaks, and load shedding is really trying to force consumers to temporarily adjust their consumption behavior. Sorry about the clicker, it's a bit bad. Let me use the laptop. Okay, before we go on, and before I'll show you a picture of what demand response looks like schematically, a couple of abbreviations. I guess these are familiar, sort of. VTN and VEN are really OpenADR related terms. VTN means virtual top node, VEN virtual end node. We'll come back to those in a minute. But let us show you a picture of how demand response actually works. Ton?
Yeah, thank you, Hugo. Yeah, we started drawing a visual representation of the glossary you've just seen. So on the left side here, it's the role that often plays the VTN in OpenADR terms. It's the DSO is there, and the DSO plays the role of the virtual top node. And then you see that we also have a business logic client in there, and business logic basically means it's a virtual role. In OpenADR earlier versions, so 2.0, it was very tightly coupled. It was often a monolithic application. So right here we have a specific set of business logic that can connect to the VTN. When you start implementing, it starts to make sense. Then on the right side, we have the energy consumers, prosumers. For example, a DSO sends an event signal saying, okay, I have a very strict grid limit at the moment, or this is what your limit will be for the next 2 days, for example. And then you see the white dots. These represent CPO parties and clusters of public charging stations, for example. They receive the events and they can send back reports with metering data saying if they can comply and such. So that's how the map looks with all the parties in there.
Yeah, and then the challenge, of course, so having one solution or one standard or one way of doing things is obviously very nice, but the real challenge is scaling this over different use cases, but also over the different actors that we have in the grid. And you can easily imagine, of course, that, for example, CPOs have different requirements than maybe in the future residential homes that can be connected as well. And they have different requirements again compared to industrial players, for example. We strongly feel that the way forward is to build on open standards, in particular to build on OpenADR, given the traction it already has. And of course, everyone should use open source software if you want to run this and use Openleadr-rs.
All right. Yeah, let me do. Yeah, sure. What is OpenADR? How did it get started? OpenADR was founded by the Berkeley National Laboratory. So they have a specific department for demand response there. It then transformed into the OpenADR Alliance. A very important step is to always have some sort of governance when you create something, especially in open source. Most of you will definitely agree. Then we got a few versions of OpenADR. It's always difficult to do things right the first time, but it's important to get started. So we started with OpenADR 2.0 version A, which was not very widely used. We then got 2.0b. It started in 2015. It started earlier. 2015 was the latest release. Then we got 3.0. It's quite current, so that came out in 2024. And now we already have version 3.1, which came out last August of this year. The OpenADR protocol is very broad in the sense that it supports a lot of use cases. So it could be about power limits, but also pricing base. So if we look at the USA, where this originated from, they do a lot based on pricing, where we in the Netherlands at least use it a lot for just communicating limits and surplus in the grid, for example, that you can actually use instead of doing everything pricing based. But it supports all these use cases. It's very broad, and that also is that's something you need to account for, meaning that our experience is that you need to actually narrow the amount of functionality and the amount of fields field values that you're going to support, because you don't need a lot to get started, but it has a lot if you're not cautious. So it's always good to create like your own profile on top of the OpenADR standard, and just say, okay, for example, I'll elaborate on that a bit more. For grid-aware charging, as we do, we created the Dutch grid-aware charging profile. You document it, and then you just implement the technicals that you need.
Yes, and maybe to add one more thing about the different versions that are mentioned here. These are versions of the spec. So the OpenADR Alliance governs the spec and runs spec development. And implementation-wise, 2.0b and 3.0 are now sort of the main open source versions that are available. Yeah, so let's dive into the project a little bit more. And it's maybe good to say one or two sentences of actually our motivation to get involved. So if I look at our company, Tweede Golf, we had gathered quite a bit of experience actually building internet protocol implementations in Rust. One of the examples is the network time protocol. It's used everywhere to synchronize time. It's important that it is very stable. All basically security depends on that clocks are well synchronized. If you think of it, well synchronized clocks are very important for security. And we wanted to transfer some of the knowledge that we built there to the energy domain. And our thinking was, well, if we can do software development in Rust in the energy domain, we can not only apply that sort of protocol development knowledge that we gained, but also hopefully in the end contribute to a slightly more resilient digital infrastructure. And the idea is very simple. If your low-level building blocks are resilient because they're built with modern technology, then everything you will build on top of that will be more resilient too. Lucky us, Elaad was also thinking about building OpenADR. So basically our paths crossed at the right time, about May of last year, I think.
Yeah, I think so.
Yeah, could be, yeah. And we actually decided to join forces.
Let me interrupt you shortly. I think I missed in my introduction. So I made the assumption everybody knows Elaad. It would be nice if everybody did, of course. But Elaad is a non-profit founded by the Dutch grid operators. So they work together there to work on things like standardization. We started from a very heavy EV side. That Elaad in Dutch, it's electronic charging. We gained a lot of knowledge. We put in a lot of charging stations to get started with EV in the Netherlands, and we now transformed more to a knowledge and innovation center where we, guided obviously by the grid operators, we work on standardization. So we still have the EV protocols, OSPP, for example, in our portfolio. And we do a lot on data, on outlooks, so looking at the growth of EV, but also not just cars, but also buses and build zero, so zero emission building. And one of the things coming from Elaad and a wish from the grid operators is to have a way to communicate these constraints. So that's a bit of background why Elaad was looking to build something like this, and then we found Hugo and Tweede Golf to cooperate.
Yeah, and for us, this is obviously a dream partner to work with, as we had very limited knowledge so far in the energy domain, but we've been working hard on that. Anyway, so fall of last year, the project actually becomes part of Openleadr, which already had the 2.0b version that was started by Elaad years before. And that actually has also been pretty good. Everyone probably knows LF Energy offers sort of a neutral collaboration space. And also the Openleadr project was sort of known with some people. So making Openleadr-rs part of that was only natural. In July of this year, it had its first annual review, was then still in the incubation stage, but of course we hope to move to early adoption pretty soon. Can you do some of the features that we actually offer?
Yeah, sure. Yeah, and that helps me to elaborate on the short introduction I did earlier. So for us, the most important use case to get started with is grid-aware charging, netbewust laden, and Dutch. We actually have a national-wide program working on this. So that's the, I think we got
We'll get to that.
We'll get to that, yeah. And we have a wish to, when we see that we have congestion on specific parts of the grid, we are very much, we were very much looking for a way to communicate this to CPO parties. So in public tenders, CPOs need to be able to receive signals, congestion signals now, and to adhere to them. So we had the rules there, but no technical implementation. So we joined, we made a working group with the DSOs, with some CPO parties, and we started thinking on, well, what do we need? What do we need to have in there for a first version? And from that came the grid-aware charging specification. So what we offer there is, together with Tweede Golf, we built a very stable VTN, so a server component for OpenADR communication that the DSOs can actually adopt. In there is also the Rust building blocks for a VEN, so a client implementation. But since OpenADR 3.0 is built on HTTP API principles, so CRUD, you can also implement the client in another language if you would want, but I think it's an easy starting point to just use what we built together. Specifically, this implementation that we built together offers a few additional benefits. So the OpenADR Alliance is very much about open, and they just provide the very big PDF file of the standard without the actual implementation. So while implementing, we found that you need a bit more fine-grained access control, for example, because you have some sensible information, for example. So CPO parties receiving information should not be able to look at each other's profiles, for example. So we put in some more fine-grained access control there. We do everything polling based at the moment. That was the first step in getting this deployed, getting this out in the open. But we're also looking at subscription later on. I think we have another slide to elaborate on that. And well, it's been a pleasure to use the project. So it's quite small. It does what it should do. It's very well documented. We already see a bit of community forming around it. And it's a big help that we were able to place it under the LF Energy umbrella.
All right. Yeah, and indeed, a pretty small so far and well-tested project. But before I go into the testing, a quick word about Rust, because I've mentioned this programming language already a couple of times. Well, I actually already said it, probably most of it, in my introduction and talking about our motivation for getting this project started. there's just a strong feeling that low-level software, where a lot of other people will depend on, needs to be built with modern, stable technology. In the end, it's all about reliability. And our experience over the past, maybe even 8 to 10 years building projects in Rust, gave us really this strong feeling that this is the right technology for the job. Also, a Rust application is very easy to deploy. It's just a single binary. You don't need anything fancy in your environment. Rust adoption is growing very well. So also for making the project interesting for external contributors, so people who want to get started doing Rust, we thought this would be a good choice. And finally, interop basically relates to what Ton just said. Many people ask, well, okay, but can I then run this within my Python environment? And the answer is, yeah, you don't really have to do any interop, as all components of OpenADR talk HTTP to each other. So that's super easy, basically. Okay, then to the testing. You of course see the 40 failed first, right? Everyone notices the red. No, but it's actually not that bad. So of all tests that are applicable to what we've built, actually 2 of the tests fail. And the test that I'm showing here, it's actually the closed source test suite that the OpenADR Alliance offers. It's used to verify that your implementation is up to spec or complies with the current spec. And as we just told, we deliberately deviate in some parts from the spec, for example, regarding the subscription feature and regarding permissions management. So actually, almost all of the applicable tests for implementation pass, which is pretty good news. Zooming out again and talking a little bit about adoption, right?
Yeah. Well, it's always good to have a business case waiting for a technical solution. So once we had the first version of the implementation, we actually told, we have 3 DSOs and 8 CPOs, and we already were talking with them. We already talked for months about the internals of the Dutch grid-aware charging specification, but that was just on paper. So no implementation yet, just which field names, which field values are we going to use, and what are we going to support later on. So what do we need for the first release? And from that came the grid-aware charging specifications, and we now have CPOs actually starting to implement what we wrote in a very big PDF file again, but that's just what you have to do to get started. We now see that CPOs, first we're thinking, DSOs, sorry, the grid operators, we're first thinking, okay, well, what's this open source that you're talking about? Is it safe? Do we have a governing structure? Is it something that will exist in the next 10 years, or will it be like a one-day fly kind of thing? Well, we were able to assure them that it's something that's here to stay for the long term. So now the DSOs are starting to implement the VTN role based on Openleadr mostly. So 2 of them already said they're going to use it. 1 is lagging a bit behind, but they're also looking at Openleadr as their VTN solution. Then we have 8 CPO parties connected that cover quite a bit of the Netherlands geographically. They only need to implement the VAN side of the OpenADR connection, which is again HTTP. So they don't have to adopt Rust if they don't want to. If they already have parts written in Rust, they just use the VAN building blocks that we gave them. Otherwise, they just implement an HTTP client. They tie it into their CPMS software, their backend, and they can start receiving our event signals. And what are these event signals? We calculate, or the DSOs, so the grid operators, calculate the surplus of room that there is on the grid, so within the limits that they calculate for the future. And we always communicate a rolling window of 48 hours where they know what's coming towards them, so they can start planning, they can do their energy management properly. And they receive this message once a day. So they receive it for tomorrow and the day after, and tomorrow they receive for that day after and the day after that, so they can optimize their EMS based on new information from our side. And they do that polling based, so we have the wish to do that more real time in the future, but for now this is already very good. just to show how we do it before, we had CSV files and such, so we did it statically. We just communicated, okay, here are your grid limits for the next few days. Import it into your tools from a CSV export, and we now do it on a standardized way, which is already a very big step forward. Oh yeah, the last, I think it's very important that I don't miss it. So also to make sure that everybody complies, everybody is using the specific grid-aware charging specification. We created our own compliance tooling. We asked another small company to build it for us. So that's not an OpenADR specific test tool, but it's a grid-aware charging test tool. So you test a little bit of the OpenADR that's underneath, but it specifically verifies that you use the field names and the values that we agreed upon together. So it really is a Dutch grid-aware charging compliance tool that's also available to both the DSO and to the CPO.
I see we have to speed up a little bit if we want to make it in time. You want to continue?
Yeah, sure. Okay, so now we do public charging stations, but why stop there? We also see a lot of need for other fields of or other places to do energy management. So we're also looking into applying what we learned here and the building blocks we created to apply that to residential loads, use it to control homes directly or via aggregators in between. That could also help us to fight grid congestion that we see on multiple levels in the grid. So we're now more focused on the medium and low voltage side, but maybe even on the high voltage side, there's something that Openleadr or OpenADR together with Openleadr can do. And we're actually now building the first V2G OpenADR enabled demo where we can send a DSO signal to a CPO that will then trigger a charge point to do a V2G charging session. So we're able to utilize the car's power to balance the grid if needed. It's a very nice demo setup. It's not production anywhere near, but it's good to have this full chain set up somewhere and to show that it's actually technically possible. So we'll demo that at the ElaadNL premises in Arnhem at the beginning of October.
Yep, and then we're getting to the final stage of this talk. Looking ahead, of course. So what's on the roadmap? A bunch of technical stuff, of course, not that much, but the 3.1 spec just got released. So we're planning to open a 3.1 branch in the coming weeks, basically. We will also be implementing the subscription feature. We'll base it on WebSockets, first of all, and then see later if we run into scalability problems, and then maybe do something based on MQTT as well. And also maybe even spec the WebSockets-based notification mechanism in 3.2, for example. We are very much in contact with the people from the OpenADR Alliance working on the spec, and yeah, they're super willing to do that. Also non-technical things, securing some funding for the project, in particular for maintenance in the next year. We feel if you want to do serious open source projects, you need funding to properly maintain it, etc., etc. So that's also on the roadmap. And we want to publish an official field test ready release as some sort of a marker. Well, hey, we think the project really is in a good shape now. To close off, so ElaadNL and us, Tweede Golf, we will stay very much committed to the project, and yeah, we'll continue working on it. But of course, you can help too in several ways. Come talk to us. Maybe we have time for 1 or 2 questions after the talk, or otherwise catch us during the break. LF Energy Slack, there's an OpenADR channel. You can ask your questions there. Join one of the technical steering committees. Those are public. Very easy to join, and you're up to date immediately. And of course, you could help write code, create a PR, or maybe even your organization is willing to financially help the project, which then can be done through Trifecta Tech Foundation. And then Trifecta will make sure that it's transparent, like how this funding is to what maintainers that funding is given. I think that's all we have for now, right?
Yeah, that's it.
Cool. Thanks for your attention. Yeah, we're over time, but can we take one question or? Very quickly, yeah.
Oh yeah, sure.
You have to get.
Oh well, he sets up.
Okay,
Yeah,
sure.
Yeah.
Is there a question? Yeah.
Yeah, very interesting. Have you looked into Shapeshifter, which is also used in the Netherlands with the GoPax ecosystem, and how would both of these standards, would they have to collaborate? How would they collaborate, Shapeshifter and OpenADR and Openleadr specifically?
Yeah.
Can you answer that one, or?
Yeah. We do know Shapeshifter, obviously, at ElaadNL. It's also one of the ElaadNL projects. I think we saw a bit of a movement and a wish for quite an easy protocol. We deliberately chose to not create something new, but to pick something that we have in the open source portfolio available. It's a decision based on ease of use. I think the API is very easy to set up. It's a very limited message set when you start applying it, for example, in grid-aware charging. So that's purely what drove the adoption of OpenADR instead of Shapeshifter.